I'm going to work example 3 from section 3.2 exponential functions. This is in your packet. So we have in example 3, we're given a word problem. So instead of given the function and sort of dissecting it, we're given a word problem. So we're told that we have a town that has 70,000 people to start. Okay, when you see to start or to begin with, it's sort of a key word to let you know that this could possibly be your initial amount. So when we start, we're at time 0 and we have 70,000 people. Okay, and then suppose that that population increases by 1.8% per year. So we're given an increase, it tells us an increase, and it gives us a percent. So that is our percent, our rate in a percentage form, 1.8%. But when we write our equation, we always want to have it in decimal form. So I'm going to move the decimal to the left 2 places. So R would be, as a decimal, 0.018. Okay, so that's a couple pieces of information that we have. So then we're going to want to find B, we're going to find A, because we want to write it ultimately in exponential form here. So in fact, down here it says find a formula for the function that gives an output of population of the town in years of the town after X years. Okay, so I just kind of color coded these. Population is our output, our input is years. So when we want to try to write this function, I'm going to input how many years have passed, and I'm going to get an output of population. So if we want to find that formula, well, let's go back up here. We have 70,000 people to start. Okay, I'm given R. If I want to find B, I'm going to do 1 plus R. Okay, so B is 1.018. I just added 1 to R, get down here, and I can write this function. F of X is equal to 70,000, and my B value is 1.018 raised to the X, and that is going to give me an output of population. So if I want to sketch this thing, before we go ahead and put it in Excel to find a couple of additional points, I already know that my y-intercept is at 70,000. So let's say this is 50,000, let's say this is 100,000, 150. I know that I'm going to go through the y-axis at the point 70,000. And because I know that this is growth, right? R is positive, B is greater than 1, I know it's a growth function. So I can sketch this without finding any more points, just like this. You know, this is just a very rough sketch. I know that I'm going to have a horizontal asymptote on the left, and it's going to shoot up to infinity on the right tail. But let's find a couple of additional points here. So what we did here, this is the y-intercept, right? If I put in 0 for x, that is 70,000, 1.018 raised to the 0, which is 1. So that is the point 70,000, which we already knew that A represents the y-intercept. But again, really all we're doing is plugging in 0 for x, and that results in the y-intercept of 70,000. All right, let's go to Excel and put this into Excel. So if I go to Excel here, I've set up my input-output table. All right. And I have my x values, and I want to input this function is equal to 70,000 times, I really don't need that, times 1.018 raised to the x power here. And enter. And in fact, I can see here, right, when x equals 0, y equals 70,000, that's my initial amount. In this case, I started at 0 because that's when I started measuring the population. So I didn't go backwards in years. All right, let's look here. So it says find the population, which is my output, after 8 years, which is my input. So that means that I want to input 8 into my input column. I'm not using solver. When I'm given an input, I just enter it in the table, and because I have my formula over here, Excel will automatically calculate that for me. So let's see. Okay. So when x equals 8, and I could write this as, really what I'm doing in Excel is f of 8 is equal to 70,000 times 1.018 raised to the 8th power, and that's equal to 80,738 people. That's my population. After 8 years, my population is 80,738. All right. So let's look at the next part of this. Okay, just trying to get rid of that box. There we go. So then it says find when. So it wants me to find how many years, when is time, okay? When the population will be 100,000. So if I write this in function notation, it wants me to find the x value when the output is equal to 100,000 people. So this is where I'm going to use solver, right? If I'm given an output, I use solver to solve for the input. So if I'm going to go to my table here, here's my output column, and I want to sort of scroll down until I see the closest number to 100,000, which is right about here, okay? So I'm going to use solver to force that to equal to 100,000, and then it will give me how many years it takes until the population is equal to 100,000. So I'm going to do solver. I'm going to set my objective to be not that cell, this cell here. Okay, I want to force it to a value of 100,000, and I want to put the result right next to it right here and hit solve. Okay, so that tells me in about 20 years, the population will be, if I round this, 100,000 people. Okay. So I'll just come down here. So x equals 20 years. And I could write that, I could say in 20 years, the population will be 100,000 people. Or f of 20 is approximately equal to 100,000.